Hello everybody. Let me introduce myself. I am Adindra Karanam. I am working as an intern at Enver House Private Limited and I am a BTech CSE IoT graduate from Shastra University. Okay. For today, let's know about few development boards. I hope you all know these development boards which are shown in the PPT. Can you say what is the name of this board? Yes. This one? Yes. Can you say the last one? Can you know the model and version? It is a Raspberry Pi 4 B+, right? Yes. Today we are going to see about the Sprout development board which is designed by Enver House Private Limited. The agenda of this presentation is, first of all, let's know about the board, Sprout board, then the tools required to program with this development board and how to do the programming and basic sensor and an actuator interfacing with Sprout board. Yes. I hope you can see this. This is a Sprout board which is designed by the Enver House Private Limited. The main features of this Sprout board is it is equipped with ESP32E microcontroller chip inside the development board and it has Wi-Fi and Bluetooth built-in option. Wi-Fi is a wireless protocol which is adapted from IEEE 802.11 and Bluetooth BLE, Bluetooth Low Energy. It is a wireless protocol which is adapted from IEEE 802.15.4 and this microcontroller chip, it works on 3.3 volts and you can see this. It is a USB type programming interface which is given for this programming board and in order to power this board you can use either USB or you can use DC input. And when coming to the main features, we can use this board for IoT and automation projects and we can connect the sensors, actuators and we can use this device as a gateway also. As I said, this board consists of ESP32 Groom E chip. We already have the ESP32 development board already existing in the market. So let us see what is the difference of the basic ESP32 development board with Sprout board. When coming to the voltage input, we'll give mostly the 5 volts as a maximum voltage we'll give as an input to the ESP32 development board. When coming to the Sprout board, we'll give a 7 to 24 volts as a maximum output of voltage we'll give as an input to the Sprout board. When coming to the GPIO axis, here we can use only header pins on the basic ESP32 development board. But in Sprout board, we can use both header pins as well as screw terminals which are used for industrial control also. When coming to the industrial use, a normal ESP32 will be having this limited options, but a Sprout board is suitable for the industrial purposes also. When coming to the stability, we can see some moderate stability using the ESP32, but when compared to the normal ESP32, this board will act more smarter and it is more stable for the usage in industrial purposes also. And you know, wiring we are generally using female and male jumper wires, we are using for the ESP32. Here we can either use header pins or we can use screw terminals so that we can interface without any hardware damage. Yeah. When coming to the onboard peripherals which are present on the sprout board, we can see the USB type B is interfaced on this board. So we are interfacing our this sprout board with the Arduino IDE using this USB type B port and LM2756 voltage regulator. Do you know the importance of LM2756 voltage regulator? Okay. So in the sprout board, we have some LEDs, on-chip LEDs present on the development board. So if we give the LED will have a limited, it requires a limited voltage supply in order to work. So if we give 5 volts or 7 to 24 volts input, how can an LED work? So we use this LM2756 voltage regulator in order to stabilize the current flow in the board as well as to safeguard the LEDs present on the sprout board. Okay, when coming to the FT232RL this IC is majorly used in order to convert the UART to UART or USB to the serial logic. So we'll use this Arduino IDE in order to run the program in the sprout board. So in order to use that, in order to display the values in the serial monitor, we'll use this IC. Power selector. We'll use a small jumper in order to give a supply to the ESP32 room chip here, so that it can get activated and we can see that on the when connected to the IDE. AMS the 1117 voltage regulator. Before going to this, we shall see about the 10 microhenry buck converter. This buck converter will use, so you know right here 7 to 24 volts DC input can be given in order to power up the sprout board. So if we use such a huge amount of voltage, so but the ESP32 chip requires only 3.3 volts. So in order to stabilize that voltage, we'll use 10 microhenry buck converter in order to step down the voltage. So it converts the 7 to 24 volts DC input to 5 volts. Then after converting that to 5 volts, this AMS 1117 voltage regulator further converts that 5 volts to 3.3 volts, which is sufficient for the ESP32 room chip to activate. Okay. Next, onboard GPIO button. So you know right, we'll have some buttons, program using button and some microcontroller, and we can actuate using that button. So you might have familiar with some programs, right? Button and LEDs similarly. So we are already given with some LEDs also on board. Similarly, we are also given with some GPIO button. GPIO4, IO4 means the button is communicating with the GPIO4. It is already given on the chip. So if you want to use furtherly, if you want to use, you can use this button for your any project. So boot button, reset button. Boot button we are using to dump the program in the microcontroller like ESP32 chip. If we want to store and run the program, we should use this boot button while we are executing the program in the IDE. It is must. Then reset button. Once we dump the code inside this microcontroller or development board, in order to restart the program, just press the reset button here. So the program will start again. And you know, I have said right, screw terminals are there. We can use the same header pins. Instead of that, we can also use the screw terminals for industrial, if you want to use this board for any room, like if you want to use this for smart home automation or any industrial access, you can use the screw terminals. And but if you want to use for any small projects, you can use this header files also, header pins. And this is the overall view or the onboard peripherals on the Sprout board. We have this Sprout development board pins here. We have power pins. Okay. This board we give an output voltage of both. It will give an output voltage of both 5 volts and 3.3 volts. And we have a ground pin which is used to connect a negative of any component. We use this ground pin. And 5 volts and 3.3 volts we are used to give as a positive or supply. And we have digital pins. It is generally used as input or output pins. Here we have a number of pins here. So if we want to use any sensor or actuator which has D-not or digital pin as an output, we have to use as digital pin. Analog input, ADC. And do you know about sensors, right? Sensors will have 2 types of sensors will be there. Analog sensor, digital sensor. Analog sensor will give an output in discrete values, 0, 0.1 and much more. But digital sensors will give only the output as 0 or 1. So if you want to use sensors which are giving the discrete values, you should connect the sensors to the analog input pins. And if you want to use DS pins, analog output sensors, we can use it to generate the analog voltage. If you want to convert the digital values to analog values, you have to use the DAC pins, pulse width modulation pins, which are used to generate the pulse, such as for ultrasonic sensor, we have to generate the pulse in order to make the ultrasonic sensor read the distance and output the time and then calculate the distance and say to the user. UAR, it is a serial communication which have majorly, you have 2 types of pins in the UAR communication, TX, RX, transmit, receive. And in this controller, microcontroller board, you have 2 slots for UAR serial communication. And SPI pins, serial peripheral interface. It is a type of communication protocol for high speed communication. We use these pins. MOSI, MISO, SCK, CS, MOSI, master out, slave in, MISO, master in, slave out, serial clock and CS pins. These are the, if you have to use some sensor such as RFID reader, you know, right? RFID reader. If you want to use and if you want to interface with any microcontroller board, you should use the serial peripheral interface, which you have to use those pins in order to use that sensor in your project. I2C, inter-integrated circuit. It is a type of protocol which are used for low speed peripherals. You have to use I2C protocol. SDA, serial data, serial clock. These 2 pins you have to remember in order to use I2C protocol. SK flash. These pins, you can see the pins, right? CLK, G6, SD0. Such those pins you leave in your project. Those pins you should not connect because they are used to activate this ESP32 chip. And the boot pins, I said right, in order to dump the program into this board, we have to press this boot pin while executing the program. Like before executing, you have to compile it. During compilation, it will generate a .bin file. That .bin file will be saved inside the flash memory of this microcontroller board. So the boot pin is automatic. It is internally connected with the C-mode pin. So whenever you press that boot pin, it will automatically flash the program inside the flash memory of the ESP32 chip. Okay. You know microcontroller now, as of now. It has both Wi-Fi, Bluetooth, SPI, I2C, both wired as well as wireless protocols, you know now. So, what is a sensor? Can anyone say, in your own words, can anyone say what is a sensor? Anyone can say? Can anyone? Any one of you, please stand up and say, what is a sensor? Can any one of you please stand up and say, what is a sensor? Okay. Sensor is nothing. Sensor is nothing but a device which detects the physical, chemical, biological, mechanical, any change. If it is there in the environment, working environment of the sensor, it will gather that information and convert them into the electrical signal. IoT life cycle will have 4 stages. First, data acquisition. Can you say along with me? First one is data acquisition. Second is communication. Third is computing. Fourth is visualization. These 4 are the major processes in the IoT. Any IoT project, if you want to do, make sure that you follow these 4 processes, which are data acquisition, communication, computing, visualization. So, in the data acquisition part, we will use a sensor and any microcontroller device or a development board you can use. For that one, if you use a sensor you can use for detecting these changes and converting them into an electrical signal. Why do you use a sensor? It measures the real world values and it gives an input to the microcontroller. Based on that input, you can make some automation systems, monitor the environment, and real world changes we can detect using a sensor, and that sensor will convert the raw values into electrical signal, and which is supplied to the microcontroller. Based on that, you can take some decisions like threshold, and you can make your own programs based on that. So, as I said, right, unlock sensor, for example, LM35 we use for measuring the temperature. Soil moisture sensor, this is LM35 sensor module. This is MQ131 sensor module, which is used to measure the air quality, such as NO2, O3, some pollutants of the air we can use to detect using this MQ135 sensor module. Soil moisture sensor. This is used to capture the moisture content or water content present in the soil. So you should remember that these all sensors have A0 pin, which is unlock pin. You have to interface this unlock pin to the ADC of the probe board or A0 pins, unlock pins of the Arduino Uno in order to acquire the data. These sensors will give values which are discrete in nature. You can see, right, there are multiple values in multiple units. When coming to the digital sensors, they will give output as 0 or 1. So here we have PIR sensor, which is used to intrusion detection. We can use the PIR sensor, IR sensor for obstacle detection, touch sensor for capturing the touch. So these all sensors will have the digital sensors. They will have the output either 0 or 1. If the output is 0, it means that the signal is high. If it is 1, then the signal is low. These pins should be connected to the digital pins of an Arduino Uno or ADC pins of an ESP32. Some basic communication protocols which we are using for sensor interfacing. So you can see this one. Can you say what is the sensor? RFID reader, which is MFRC522. It is a module name. The up one, this one, that is MPU 6050, which is accelerometer sensor. So this is GSM module, which we will use. We'll insert some SIM, and we can use this for SMS or call. And even like earlier, mobile phones used to have this sensor. So MPU 6050 I2C, it uses I2C protocol. I said right, inter-integrated circuit, which have SDA, SCL, serial data, serial clock. These two pins, VCC, ground. We have to connect these 4 pins with the microcontroller. Microcontroller, you have I2C pins, right? I have said right. Those pins have to interface with this I2C protocol based sensors. For GSM module, we have to use UART based protocol. UART based protocol will have 2 pins, TX, RX, ground, VCC. You have to use this TX, RX pins, and you have to connect the TX pin with the RX pin of the microcontroller, RX pin of the sensor with TX pin of the microcontroller in order to send the data in a serial communication. MFRC 522. This is a SPI based serial peripheral interface. This is the type of protocol for high speed communication. So we use MOSI, MISO, RST, recent pins, VCC, ground. So these things we have to connect using SPI protocol to the SPI pins of a microcontroller. Okay. Now coming to the actuator. Can you say some actuator present in the classroom now, in the lab now? Fan, light, monitor, AC, mic, display, any device which you want to get it work done at the end system is called as an actuator. So I said right, sensors. Those sensors will give some electrical signals, right? Based on the electrical signals, you can give some threshold, and based on the computing, you can make this actuator work well. So, an actuator is a device which converts the input signal into the physical motion or force. So, why we use these actuators in a real-time environment means we have to automate the tasks for control mechanical systems in smart industries, smart factories, and in order to convert the signals into a real-time implementation or physical action, we will use this actuator. You did some insights on some basic actuators. So, I think you might have used some of the actuators, right? DC motor. Can you say where of the DC motors mainly used? DC motors mainly used for fan, right? Yes. Buzzer, sounder, okay. Servo motor, robotic arm, that's used for solenoid lock, automatic door lock system का use करने का. Radio motor.
Lights off.
एना वर्क करना फर्स्ट रिले मॉड्यूल वर्क करना सरिया रिले मॉड्यूल में main use is it will convert, it is like a voltage regulator. Mainly the voltage of the relay module input is 5 volts. The output will be 12 volts mainly. So the most of the actuators will have 12 volts as an input. Water pump can use and the water pump agriculture. Yes. Now we'll see about the programming. I think already you have known that Arduino is mainly used for Arduino ESP32 and even the Sprout board. We are using the Arduino IDE and whenever you want to do some projects, you have to use the latest version of Arduino IDE. And in order to install some boards into the Arduino IDE, you should install the particular board name in the board manager. Using the board name and its original designer, like Esprit Systems is the founder of the ESP32. So you have to install the board library using the board manager in the Arduino IDE. So once you have opened the Arduino IDE, you will use the USB Type B or Type C, right, for connecting the board with the PC or laptop. So once after connecting, you have to select the board and the port number. Once you connect the board with the laptop, you will see something like USB and port number. So you have to click that and you have to select the board name. Previously you might have installed the board, right, in the board manager. That board you have to select in the boards. So then now you want to create one project in using Arduino IDE. So you have to go to the file, new sketch, and you should start writing the code. So once you write the code completely inside the sketch, inside the area given there, you have to compile the code first. Right? So once you compile the code successfully, you have to upload the code inside the. You have to dump the code in the code. So if all the code is working properly, you can see that sketch uploaded successfully. For ESP32, you have to press the boot button. Once your code is compiled properly, then you have to upload, right? While uploading, you have to press the boot. In middle, boot button is there, right? That boot button you have to press.
Actually, this is your lens, right? This is your lens.
Tag. இதுல some chip மாதிரி வச்சிருக்காங்க இதுல. இது அந்த டிடெக்ட் பண்ண ஆப்ஜெக்ட். ஸோ நீங்கள் இப்போ ஆட்டோமேட்டிக்காக எனி டிவைஸ் ஏதாச்சும் you can capture and it will show UUID. Every tag has a separate UUID. இப்போ நீங்கள் ஆல்ரெடி சேவ் பண்ணிருந்தீங்கன்னா இந்த மாதிரி சும்மா நார்மல் டேக் இதில் இது டிடெக்ட் பண்ண அந்த இந்த மாதிரி மெட்டீரியல்ஸ் கேப்சர் பண்ணி இல்லை இந்த கார்டோட ஃப்ரீக்வன்சி இது மேட்ச் ஆகிடுச்சுன்னா ஆட்டோமேட்டிக்காக ஃப்ரீக்வன்சி பேஸ் இந்த மாதிரி கார்டு இன்னும் நிறைய வேறு ஃப்ரீக்வன்சி ஹை ஃப்ரீக்வன்சி இருந்துச்சுன்னா ஒர்க் ஆகும் சேம் சைஸ் சேம் கலர் இருந்தாலும் ஒர்க் ஆகும் ஸோ நீங்கள் ஃப்ரீக்வன்சி மேட்சிங்கு பார்த்தா அப்படியே பவர் இதெல்லாம் பார்க்கலாம் சீரியல் பெரிஃபரல் இன்டர்ஃபேஸ் ரீடர் டேக் இது எதுக்கு யூஸ் பண்ணுறோம்னா இப்போது லைப்ரரியில் இந்த ஆத்தரைசேஷன் மிஸ்ஸில் நம்ம சாப்பிடும்போது கார்டு இந்த மாதிரி ஆத்தரைசேஷனுக்காக இது யூஸ் பண்ணுவோம் இந்த யூபிஐடி வச்சு நம்ம பேர் ரிஜிஸ்டர் பண்ணிவிட்டு அது அவங்க டேட்டா பேஸ் யூஸ் பண்ணுவோம்